Gábéil sa cuaigdig pápéir dó ceiste 3. The coordinates of 2 points are a 4 minus 1 and b 7t. The line L1 3x minus 4y minus 12 is equal to 0 is perpendicular to AB. Find the value of t. So the key to the question really is the fact that we have a line that's perpendicular to another line that contains the points AB. That means that the slope that the points A and B are on is going to be inverse to the slope of L1. So the first thing I'm going to do is identify the slope of L1. We find the slope when it's in this format ax plus by plus c by taking minus a over b. A being the coefficient of x, so that's minus 3. B, the coefficient of y, minus 4. So that will simplify to give us 3 over 4. We could change L1 so that y is the subject and write it as y is equal to mx plus c. And then the slope is the coefficient of x. If we do that, we'll find the same thing. We'll still find 3 over 4. So now I'm going to find the slope of AB. Using those 2 points, I'm going to call it M2. So we use our formula, y2 minus y1 over x2 minus x1. So when we substitute in our values, we're going to get t plus 1 over 7 minus 4, which is just going to simplify to give us t plus 1 over 3. So because M1 and M2 are slopes of perpendicular lines, it means that I know that M2 is going to be equal to minus 4 over 3, so the inverse slope of M1. So I can let this be equal to t plus 1 over 3 and solve for t. Alternatively, for perpendicular slopes, M1 multiplied by M2 is equal to minus 1. So I could multiply the two, let them be equal to minus 1, and again solve for t. Again, I'm just going to find the same thing. So if I multiply both sides by 3, the 3's will cancel. I'm going to be left with minus 4 is equal to t plus 1. So therefore t is going to be equal to minus 5. Part B, find in terms of k the distance between the point P and the line L1. So the distance between a point and a line is the perpendicular distance. So the first thing I'm going to do is write in the formula for that distance. So we have ax1 plus by1 plus c over the square root of a squared plus b squared. So a, b, and c are coming from L1. The coefficient of x, the coefficient of y, and the constant. And x1 and y1 are coming from P. So I'm just going to substitute in those values. And then continue to simplify. So 13 minus 12, we're going to get 18 minus 4k. And that's going to be over 5. So we have d in terms of k from the point P to the line L1. Part C, P, 10k, is on a bisector of the angles between lines L1 and L2. 5x plus 12y minus 20 is equal to 0. Find the possible values of k. So I'm just going to do a sketch to kind of illustrate what exactly they're talking about. We have two lines, L1 and L2, and the point P is on the bisector of the angle of those lines. So if it's on the bisector of the angle, we know then that the distance from P to L1, again we're talking about the perpendicular distance, is equal to the distance from P to L2, and again perpendicular distance. So the d that we found for part B is going to be the same as the distance from L2 to P. They want us to find k. So if the two perpendicular distances are equal to each other, then we'll find the perpendicular distance from L2 to P. This will be in terms of k. We'll put the two distances equal to each other and we can solve for k. So again, we're using the formula we used in part B. So this time our A is 5, B is 12, and C is minus 2. And we're using the same x1 and y1 for 10 and k. So I've just substituted in the values, and now I'm going to simplify. So we're going to get 30 plus 12k over 13. So I'm going to call D1 the distance from L1 to P, and D2 the distance from L2 to P. these distances are equal, I'm going to let them be equal and solve for k. So in part B, we found that d was equal to 18 minus 4k over 5. So this is now going to be equal to 30 plus 12k over 13. So if we didn't have the modulus symbols, we'd just go ahead and solve it like any equation. But because we have the modulus, we have to consider the positive and the negative. First thing I'm going to do anyway is multiply the left by 13 and the right by 5. So on one side, as I said, if we're getting rid of the modulus signs, I have to consider the positive and negative. Doing it this way saves me from having to square everything, ending up with really big numbers and then simplifying and solving a quadratic. But it can be done that way as well. So now I'm going to just continue and multiply both sides. And now to solve for k, I'm going to consider the positive and the negative separately. So I'm going to have 234 minus 52k is equal to plus 150 plus 60k. And 234 minus 52k is equal to minus 150 minus 60k. So we see this when we're using the minus b plus or minus formula. It's a similar idea here. So when I simplify on the left, I'm going to get 84 is equal to 112k. So therefore k is going to be equal to 3 over 4. When I simplify on the right, I'm going to get 384 is equal to minus 8k. So k is going to be equal to minus 48. So I have two values for k. So the last part says that if k is greater than 0, find the distance from P to the line L1. So if they're telling me k is greater than 0, I can't use the minus 48 value. I have to use k is equal to 3 over 4. They want us to find the distance between the point and L1. We know for that distance we had 18 minus 4k over 5. So all I'm doing is substituting in 3 over 4 for k. So 18 minus 3 is going to give me 15. So the distance is going to be equal to 3. So we weren't given any units of measure for this, so we don't need to include them in our answer. But if they had mentioned anything about centimeters and meters, we'd have to consider putting in units for any distance if we find it as an answer.